Hello dear students, good evening to all of you. Welcome to you all on IMS Gate Academy YouTube channel. I am Ankur Sharma, Associate Director IMS Gate Academy. Welcomes you all on this YouTube channel. In today's session, we are going to discuss about the discrete time Fourier transform. In the last session, we have completed discrete time Fourier series part, and I hope you guys attended that session and many of you watching in recording also. So whenever you will watch the session, even in the recording or in the live, if you feel that if you are getting a good content, guys, you should try to make your class handwritten notes also, and you should share your feeling in the comment section also. So before going to start this discrete time Fourier transform, first of all, I just like to inform you about the IMS Gate Academy program features. We just take a 1 minute time and I will brief you in the detail. We'll discuss in the last of session. So IMS Gate Academy offering, guys, 4 types of courses. We are providing offline classes, weekend batch, offline classes, weekday batch, dropper batch also we have. We have the live online batches also, as well as we have the self-learning program also. Once you will join any program, you will get 800 plus live lecture access, theory book, exercise books which contain 4000 plus practice question, 34-year GATE question booklet with video solution, 12 one-to-one mentorship session, 130 online test series which include chapter test, subject test, advanced level subject test, multiple subject test, as well as we have mock test. So student, if you have any queries in detail, you can discuss your queries on this mobile number. You can contact WhatsApp. You can WhatsApp also, you can just call also. Student, if you want to get updated, if you want to get any update from the IMS Gate Academy YouTube channel, any live session, if you want PDF, as well as if you want to know about the latest job notification and expert sessions, daily quizzes, then you can join our Telegram group or official IMS Gate Academy Telegram group. Link is given in description. You can find the group and you can start. Yes. So student, today's class we are going to start with discrete time Fourier transform. So first of all, I just want to check whether you know about the CTFT or not. Have you heard the name of continuous time Fourier transform? So we will first initiate from the continuous time Fourier transform, and then eventually we will jump to the. So here I am taking this pen. Yes. So guys, we'll discuss about DTFT, but first what I am doing now, I am just writing here CTFT formula, then after that we will write the DTFT formula. Okay. So first in this part I will write my continuous time Fourier transform formula. So student, how many of you know about continuous time Fourier transform CTFT? And here we will discuss about the discrete time Fourier transform DTFT. I am telling you guys one thing, if you are sincerely dedicated for the GATE exam, if you are preparing for the GATE exam, if you want a good rank in the upcoming GATE exam, and when you will watch the session continuously 30 minutes, 1 hour, definitely you cannot stop yourself to watch next videos. Okay, so here in this playlist we have 67 videos till now, and very soon it will become 80 plus also. It up to you only, guys. If you want to support if you want to know, if you want more videos, then you should attend all the session in a live manner, so that me and my all team members, my faculty members will take more and more YouTube live session for you. Okay guys, if you want more sessions, then you have to come in the live manner and try to interact. Okay, and if you have attended the session live manner, you just share your experience also. So continuous time Fourier transform, guys, the formula of CTFT is nothing but x omega. Continuous time, so of course integration minus infinity to infinity xt e to the power minus ka j omega t dt. I think audio video is clear. I think Mathan already yes, confirm this. So this is my CTFT formula, continuous time Fourier transform formula. Now what I am doing, guys, if I want to just jump in the discrete time domain from the continuous time domain, what I need to do, I just perform sampling. I need to perform sampling, guys. I need to perform sampling where we need to replace t with nts, where we'll replace t equal to nts. So if I will do this, the discrete time Fourier transform in the discrete domain, the presentation is x e ki power j omega. The integration will be changed with summation. T will be changed with n, so limit of n minus infinity to infinity. Xt will be converted in the discrete time domain and will be represented as x of n. And in place of exponential e ki power minus ka j omega, in place of this t, I am putting nts. I am putting here nts. Now what I am putting, guys, this is the overall values. Now in the next equation, what I am writing? I am writing this sigma of n equal to minus infinity to infinity. Here I have x of n e to the power minus ka j omega. Even ts also I am writing here, and then I am writing n. And this complete frequency is working as a discrete frequency omega d. So I am representing as omega d. I can write as only omega also. So omega d is nothing but omega ts, where you can also write omega d as a discrete time frequency. This is sampling time. So I can write as a omega d equal to omega, and we know that ts is nothing but 1 upon fs. Ts is nothing but 1 upon fs. So when you will write like this, you can say. So omega d is the frequency of discrete time domain signal. It is a discrete time domain signal frequency. Omega is the frequency of continuous time domain signal, and fs is the sampling frequency. So this is the relation between the discrete frequency, continuous frequency, and sampling frequency. Even I can write in the form of hertz also, f also. So omega d is nothing but 2 pi fd, and I can write here 2 pi f and upon fs. So don't you think this 2 pi get cancel out? So the final expression that you can get here, that is of course important. I am just keeping this expression in a box here. So fd equal to, I am writing here, fd means discrete time frequency in hertz, equal to f upon fs, is equal to f upon fs. Of course fd is the discrete time signal frequency, f is the continuous time frequency, and this is the sampling frequency. So again a very important result we got here, this. So now student, if I will replace this omega d, then my formula will be written as a minus infinity to infinity x of n e ki power minus ka j omega dn. And this is nothing but the DTFT formula. This is nothing but the DTFT formula. Just make it fast. Just do it fast, guys. So this is my discrete time formula. Just complete this part. I'm just waiting for you. So guys, once you will complete, I am just going next slide, and I'm writing here. I am writing here the again discrete time formula finally. So x e ki power j omega. The formula is nothing but that we have to remember minus infinity to infinity x of n e to the power minus ka j omega n. Here omega is representing discrete time frequency. It can be omega d, it can be omega s, whatever you can write. The notation we can define earlier. I have denoted as omega d. Right now I am denoting as omega only. Okay. Now I can denote as a continuous time frequency as omega c also. Na? So this is my DTFT formula. This is the formula of discrete time Fourier transform. We have to remember this formula. This is the first thing that we have to remember. Now student, again coming to this part, what is the condition of existence? So if I am talking about condition of existence, okay, I am writing here condition for existence, of CTFT, condition for existence of CTFT. Then if you know in the continuous time domain, we can write in the discrete time domain also. So same condition for existence, same we should write condition for existence of DTFT, discrete time Fourier transform. So this is the discrete continuous CTFT, and this is the DTFT. Now student, I am just writing the formula first, x omega. The formula says that minus infinity to infinity xt e to the power minus ka j omega t dt. This is my formula, guys. This is my formula. This is my formula. Now, student, this is my continuous time formula, and what is my discrete time formula? Discrete time Fourier transform formula, x e ki power j omega is nothing but sigma of n tends to minus infinity to infinity x of n e ki power minus ka j omega n. This is the formula. And do you know what is the condition of existence here? The magnitude of this, the magnitude of x omega should be less than infinity. So magnitude, if you will take now, you will get actually minus infinity to infinity x of t into e ki power minus ka j omega t magnitude and dt and less than infinity. And we all know that ki e ki power minus j omega t ka magnitude to always 1. And if its magnitude is 1, what is the condition? Condition is nothing but minus infinity to infinity mod of xt dt should be less than infinity. Should be less than infinity. Ye session. And this is nothing but the condition, the absolute integrable condition. This is the condition says that xt must be bounded. Xt must be bounded. Must be a bounded signal. It means if xt is not a bounded signal, we cannot find out the Fourier transform. We can only find out the Fourier transform of the signal. Those are bounded signals, stable signals. And this is the condition known as absolute integrable condition. Absolutely integrable. Absolutely integrable. So this is known as absolutely integrable. Now what will happen here? Here condition again says that ki sir x of e ki power j omega mod should be less than infinity. So here if you will take the magnitude, summation is there in place of integration in CTFT. So here when you will take the magnitude, you will get again x of n into e ki power minus ka j omega n less than infinity. And we know that the summation of e ki power minus ka j omega n will be always equal to 1. So this magnitude is 1. It means what we will get? We will get this, sir, sigma of n equal to minus infinity to infinity mod of x of n should be less than infinity. Should be less than infinity. Is this clear to you or not? And this means what, guys? This means what? This means xn is a absolutely integrable signal. Xn is an absolutely integrable signal. Absolutely integrable signal, or action should be a absolutely a bounded signal. Action should be a bounded signal. So student, in general we can say that we cannot find out the Fourier transform of unbounded signal. Whether I talk about CTFT or DTFT, we cannot find out the Fourier transform of continuous time signal, as well as we cannot find out the Fourier transform of unbounded signals. we can only find the Fourier analysis, Fourier transform for a bounded types of signal, whether we talk about continuous time or talk about discrete time. So I think you guys complete with this slide, just complete this. If you are watching the session, you should reply in the chat box also. You must reply in the chat box also, yes. Chaliye bachcho. So what we are doing, if I am just continuing this with examples also, then tell me what are the examples where Fourier transform applicable. You can say that, guys, in terms of CTFT, in terms of DTFT, what is bounded, what is unbounded. So if I talk about e ki power plus 2t ut, let me take some example. So e ki power 2t ut is exponentially growing signal. If you will make the curve, you get a curve like that. So this is an unbounded signal. If xt is this, then it is an unbounded signal. Then it is a unbounded signal. And we know that for the unbounded signal, Fourier transform we cannot find out. So Fourier transform is nothing but can't determine. Can't determine, guys. We cannot find out the Fourier transform of this signal because the reason is it is an unbounded signal. And similarly, in a symmetrical way, if I take the example of discrete time signal, and let me take the example of 2 ki power n un. So 2 ki power un is also exponentially growing signal. If you will make the curve of this, here n value, different values of n ki value 0, 2 ki power 0 is 1, 2 ki power 1 is 2, 2 ki power 2 is 4, 2 ki power 3 is 8, like that we are growing, like that we are growing. So we are having exponentially, we are having this exponentially growing signal. So exponentially growing means this is also an unbounded signal. So if you wish to find out its DTFT, then the answer remains same, can't determine, guys. Can't determine. And what is the reason? If examiner will ask the reason, then you must say that because it is an unbounded signal. We can only find out the Fourier transform of a bounded signal. We can only find out the Fourier transform of a bounded signal. It means, I hope you remember the Fourier transform of continuous time, e ki power minus at ut, because it is a bounded signal. E ki power minus at ut is a bounded signal because the curve is this. This is 0. This is x of t equal to e ki power minus at ut. So exponentially decaying curve. So because it is decaying curve, its CTFT is possible. And what is the CTFT? 1 upon e ki power minus at ut 1 upon a plus j omega. This is the Fourier transform. Why it is possible? Because this signal is a bounded signal. Because this signal is a bounded signal. So that is why its Fourier transform is possible. That is why its Fourier transform is possible. Similarly, here if I want to relate with the CT to DT domain, I can write ki an un Fourier transform is possible if a value is less than 1. If a value is less than 1, then only DTFT is possible. Then only DTFT is possible. For mode of a is greater than 1, can't determine. Can't determine. I hope you are getting why. Because if mode of a is less than 1, then only this entire signal is bounded. Then only this entire signal is bounded. Because 2 ki power n un is unbounded because a is greater than 1 here. Because a means 2 value is greater than 1. But if I will take the example of half ki power n un, half ki power n un, Fourier transform is possible. Half ki power n un, DTFT is possible. Why possible? Because it is an unbounded signal. Yes. Because it will be an unbounded signal. Yes. Chaliye guys, so just complete this part. I hope we can further also make a difference in CTFT, DTFT as far as inverse DTFT formula is concerned. So student, if we talk about in the yesterday also we have seen one good gate problems of 23 where it is where the question was in the continuous time domain if the signal is continuous plus periodic, then in the frequency domain it should be what? Okay, continuous plus non-periodic should be continuous plus non-periodic. Continuous plus periodic should be discrete plus non-periodic. Like that, discrete plus non-periodic should be continuous plus periodic, and discrete plus periodic will be discrete plus periodic. That we have seen in the last class only. So here in the CTFT what is happening? In the continuous time domain what is happening? In the CTFT, continuous time domain, we will talk in the left hand side, and we will talk about DTFT in the right hand side part. So if I talk about the continuous time Fourier transform, so you should tell me guys, continuous time Fourier transform, inverse Fourier transform xt formula is nothing but 1 upon 2 pi from minus infinity to infinity x of omega e ki power plus j omega t d omega. And why we are using integration here and limit from minus infinity to infinity? Because we know that in the CTFT, we have the signal continuous plus non-periodic in the time domain. Similarly, in the frequency domain, what will happen? In the frequency domain, we have continuous plus non-periodic signal. It means xt is continuous plus non-periodic. So this x omega is also be a continuous plus non-periodic only. That was the question we have solved in the last class. Because it is continuous plus non-periodic, here also integration, and in the continuous in the Fourier transform formula also integration, and in the inverse Fourier transform formula also we have integration. But what is happening here, if you will talk about x of n here, it will be 1 upon 2 pi, and here also integration, but from minus pi se leke pi, and x e ki power j omega, e ki power plus ka j omega n and d omega. And why? Now the question is, in the DTFT formula, we have summation, but in the IDFT formula, this is the IDTFT, inverse discrete time Fourier transform. This is inverse continuous time Fourier transform. Why it is happening, guys? Because if I will take x of n signal as a discrete plus non-periodic, in the continuous time domain, then its frequency domain x e ki power j omega must be continuous plus periodic. And I will show you very soon with the example. I will show you very soon in the example. Okay, this discrete plus non-periodic signal, when you will find the Fourier transform, it will be continuous and periodic, and it will be periodic for the time period of minus pi to pi, with the time period of minus pi to pi. Let me take one example, one small example. If you know the continuous time formula of rectangular pulse, I hope you remember. Continuous time rectangular pulse we have discussed in a very deep manner, in an amazing manner. So minus tau by tau to plus tau by tau with respect to t, if this is A and this is your tau. This is a rectangular pulse, guys, and if you remember the Fourier transform, its Fourier transform is nothing but a tau sampling of omega tau by tau. I told you multiple times to remember this. And if you will make the curve, then you will get a curve like this. You have a sampling, but sampling oscillation gradual decrease. So like that you had the oscillation. And the limit goes to minus infinity to infinity here. So this is xt, then this is x omega. But what is happening here? This is continuous plus periodic. This is continuous plus non-periodic. So here in the frequency domain also it is continuous plus non-periodic. Yeah. But here what is happening, guys? If I will take a rectangular pulse like this, I will prove very soon why it is periodic. I will take the example and will make the curve, and we will get the curve which is periodic from minus pi to pi. I will show you very soon. So right now, student, if we have the rectangular pulse like this, suppose that we have a rectangular pulse like this from this location to this location, and we have the amplitude A, this x of n from this 0 and from this n, then if you will find the DTFT now, of course you will have the sampling nature, but that sampling nature will be look like this, guys, this like this, and this is what from minus pi to plus pi. And after that eventually what will happen, guys? After that eventually it will repeat itself. If it will repeat itself means what? Again it will be like this, yeah. Like this. It means from minus pi to pi period, this nature again repeat, here. So this nature, so it means this pattern going to be repeat. So it is continuous also. So you can say that, sir, in the x of n, signal was discrete plus non-periodic, but here this x omega, here is x e ki power j omega is nothing but continuous plus periodic for the interval of minus pi to pi. That is why in the analog filter, we have the frequency range from minus infinity to infinity, but in a digital filter, we have the maximum frequency from minus pi to pi. However, digital filter is not in the syllabus of recent GATE, EC, EE and all, but earlier it was in the syllabus, so that is why many students, those prepared in 21 or before, they also studied this topic, yes. So now guys, I am going for the next and I am taking one example first, and through the example I will explain you how you will get the continuous plus periodics and all, okay. So let me take one example first of all. As I already told you the example guys, a ki power n un. Suppose that this is my x of n signal, this is my x of n signal. Let me take this slide now, we have this slide. So x of n is a ki power n un, and I already given you two conditions. If mode of a is greater than 1, then the signal will be behave as unbounded. And the curve will be look like this. Growing curve. Unbounded, so Fourier transform not possible. So DTFT not possible. Discrete time Fourier transform not possible. Can't determine. But if condition is this mode of a less than 1, then only possible. Mode of a less than 1, then it is bounded. Then it will be bounded, and if you want to make a curve, then curve also easy this time. Exponentially decaying matlab like this, yeah, discrete curve decaying. So this is possible. So this time Fourier transform possible, DTFT possible. Now if it is possible, then just apply the formula. If I will apply the formula for this signal, I know that my x e ki power j omega formula is nothing but sigma from n tends to minus infinity to infinity. I hope my voice is clear. Am I loud and clear, guys? I am very happy to see you in signals and system classes, sir. Once again, thank you so much, sir. Greet Tharan, you are most welcome, beta. You are most welcome. The last playlist 65 session already there. Yesterday I have taken one session, 66 lecture. Today we have 67th lecture. Okay. So what I want, beta, if you are preparing for the gate 25 or you already prepared for it, if you have the time right now, you can also attend in a live manner, or you can just share the session link to your juniors or your classmates or the other students, those who are preparing for the gate 25-26, so that the session will be helpful for them and they will have opportunity to make their concept strong as far as signals and system is concerned. And we'll take more sessions for you in the coming time for digital counters, for control also, according to your requirement. If you will be more active on our YouTube channel and if you will reply, yes. Chali, I am also very happy to see you in the chat section. Giritharan, you are my ex-student, you already attended the classes. Yes, I know this. So x e ki power j omega minus infinity to infinity, xn e ki power minus ka j omega n. This is my DTFT formula, guys. This is my DTFT formula. I am just applying the formula, guys. I am just applying the formula. If you will apply the formula, then what you will get the limit? Because of un, the limit should be n equal to 0 to infinity. And here you will get, guys, a ki power n dot e ki power minus ka j omega n. So what you will get from here? From here you will get n equal to 0 to infinity a dot e ki power minus ka j omega ki power n. A dot e ki power minus j omega ki power n. And do you know, student, infinite series formula, when you will apply the formula, you will get 1 upon 1 minus ka a e ki power minus ka j omega. So this is nothing but the complete Fourier transform of this signal, where what is the condition? Where the condition is what? Mode of a should be less than 1. Then only you can apply the formula. Then only you can apply this formula. I hope you remember the infinite series formula. In the CTFT, you cannot find out the continuous time Fourier transform if you don't know integration. Similarly, in the discrete time domain, you cannot find out the DTFT formula and you cannot apply the DTFT expression, DTFT formulas if you don't know infinite series formula. So if you don't know infinite series formula, no problem. I will just make a table in the next slide and you will get revise all the infinite series formulas. Okay, guys, just complete this part. I'm just waiting for you. And once you will complete, you should reply fast. Chaliye. So I think this is also completed. Yes. So guys, next I am just recalling some important infinite series formulas for you. If sigma limit n equal to 0 to infinity limit you have, and if a ki power n is there, then you can write as a 1 upon 1 minus a, but it can be only true when mode of a is less than 1. Infinite series formulas we are writing. Similarly, if sigma of n equal to 0 to capital N, and if a ki power n, then you can write the formula as a 1 minus a ki power n plus 1 upon 1 minus a, and this is true when mode of a is less than 1. Or you can say that, or it can be a ki power n plus 1 minus 1 upon a minus 1. This is actually a mathematics or aptitude part. This is not the signal and system, whatever I am doing here. It is a GP series, it is a infinite series formulas. Now student, if you know these formulas also, it is very helpful for you. Sigma of n equal to 0 to infinity n a ki power n is actually nothing but a upon 1 minus a ka whole square. It can only true when mode of a is less than 1. So some formulas table I am giving to you, just have a recall. Sigma of n equal to 0 to infinity n plus 1 into a ki power n will give you actually 1 upon 1 minus ka a ka whole square, and this is only true when mode of a less than 1. Similarly students, some infinite series formula table I am giving to you, n equal to 0 to n, it is 1, then it is equivalent to what? Sum of 1, so n numbers, n upper limit minus lower limit plus 1, so it should be equal to n plus 1. Similarly student, if you will write n equal to 0 to capital N limit, here is n numbers, then it will be capital in terms of capital limit n into n plus 1 upon 2. Similarly guys, if this question is that n equal to 0 to upper limit n, if here is n square, then it will be what guys? N into n plus 1 to n plus 1 divided by 6. Similarly guys, sigma equal to n equal to 0 to upper limit n, if here is n cube, then it will be n into n plus 1 upon 2 ka whole square. Yeah. So these are the infinite series formulas. You must remember these formulas if you want to understand the discrete time Fourier transform. If you want to secure full out of full marks in the discrete time Fourier transform, if you want to make this topic as your strength, then you should be fast and accurate in the infinite series formulas. So this is not DTFT, this is this mathematics, this is aptitude. This is mathematics aptitude, that formulas we will use in the discrete time domain, yes. So this expression we got guys, I hope you are getting this, yes. So I am just writing the again expression, my again expression I am writing, ki an un DTFT formula, an un, the DTFT formula is nothing but 1 upon 1 minus ka a e ki power minus j omega. Now guys, just for the sake of interest, I just want to prove this, ki if this xn is discrete plus non-periodic then this x e ki power j omega, it should be continuous plus periodic. I want to prove this. So student, here I am just applying the Euler form, e ki power minus j omega. How can you open this? You can open this cos omega minus ka j sin omega. So if you will open this, what you will get this guys, 1 upon 1 minus ka a, and here you will get cos of omega minus ka j sin of omega bracket close. When you will open the bracket, what you will get? You will get 1 upon 1 minus ka a cos of omega minus minus plus aj sin of omega. Yeah. So student, what you will get here? You will get 1 upon, tell me what? 1 upon 1 minus ka a common. So inside the bracket what you will get guys? Even y common, we have to find out the magnitude. So I am looking for the magnitude part for the same. So magnitude, it means, should I take under real part square, imaginary part square? Yes. So if it is my x e ki power j omega, and if I want to make a magnitude curve and angle curve, first of all I am taking magnitude. So this is nothing but my real part, this is nothing but my imaginary part. So it will be 1 minus ka a cos of omega ka whole square and plus a square sin square omega. So ultimately what you will get guys, 1 upon 1 plus a square cos square omega minus ka twice a cos of omega and plus ka a square sin square omega. प्लस का a स्क्वायर sin स्क्वायर ओमेगा. So what you will get, guys? So you will get from here 1 upon, because this is magnitude, so 1 plus a square cos square omega, a square sin square omega. So when you will take common, you will get 1 plus a square, cos square plus sin square is 1 only. And here you will get minus ka twice a cos of omega. Minus ka twice a cos of omega. And even in the under root, guys, because under root kidhar gaya? Under root is remain same, sir. Square root is remain same, na sir. Square root is remain same. Square root is remain same. Is this clear to you? I hope it must be clear to you. Yes, it must be clear to you. Chali. So student, this is your magnitude of x e ki power j omega. And if you want to draw the curve, if you want to draw a curve for this, I will write this expression in the next slide. So what is my expression, guys? X e ki power j omega magnitude expression is what? Just complete this part, just complete this till here. So 1 plus a square minus ka twice a cos omega, I am just writing in the next slide, 1 upon under root of, what was there, 1 plus a square, 1 plus a square minus ka, 1 plus a square minus ka twice a cos omega. माइनस का ट्वाइस ए कॉस ऑफ ओमेगा. देख रहे हो, माइनस का ट्वाइस ऑफ ए कॉस ओमेगा. यस, ये गाइस. So student, if I want to make a curve, if I just want to make a curve for the same, चलिए. So this is my curve of magnitude, curve for the magnitude of x e की power j omega with respect to omega. So if I let me take some value, I can take a value should be less than 1, because a value less than 1, so I am assuming a value half. Suppose that if a value is half and I am taking with omega different values, so can you please tell me at omega equal to 0, cos 0 is what? What is cos 0, guys? Cos 0 is 1 only, and a value is half, then half and 2 get cancel out. So when you will write this, you will get actually under root of 1 plus 1, that is 2, and minus ka, bolo bachcho, minus ka what? Because 2 into you will get half here, and cos 0 is again 1, so 2 half cancel, so 2 1 plus, sorry, not it is 1 plus half na, so 1 a value half ka square, so it will be 1 plus 1 by 4, 1 plus 1 by 4 and minus ka 1, so 1 get cancel out, so it will be actually root 1 by 4, so actually it is root 4, so actually it is 2. So at omega equal to 0 we will get the value 2. And don't you think if you will increase the value of omega, suppose that if I will take the omega value pi by 2, omega value pi by 2 if I will take, pi by 2 or minus pi by 2. We know that cos minus theta is also cos theta. So cos pi by 2 is also 0, cos minus pi by 2 is also 0. And if you will take the value, a value half, so then it will be 1 plus 1 by 4. So it will be 5 by 4. So it will be root 4 by root 5. Of course, it will be less than 2. So whatever the value, maybe it will be like this. Similarly, if you will just put the value of minus pi and pi. Do you know cos pi value is minus 1? And cos minus pi value is also minus 1. So when you will add this, you will get even low values as compared to the pi by 2. So you will actually, when you will exact curve, when you will draw, you will get a curve like this, guys. For different values of omega, na? For different values of omega, you will exactly get the curve like this. Yeah. So even at pi by 2, the magnitude is remain same here and here. Like that here, pi to minus pi. And again, student, the pattern will be repeat itself. The pattern will be repeat itself. Yeah. So it will be at 2 pi to 3 pi, like minus pi to 3 pi again. Similarly, the pattern also going to be repeat itself here. So you can see here this 0 and this is minus 2 pi, like that and so on. So we can say that the signal is going to be periodic from minus pi to pi, and the nature is nothing but continuous. So it is continuous plus periodic, that is nothing but DTFT x e ki power j. We have proved this, guys. We have just proved this. And even if you will make the angle curve, and do you know what is the angle equation? Because if this is your equation, x e ki power j omega, where is the equation? This is your x e ki power j omega. From this we have calculated this is the magnitude, and if I want to write the angle equation also, then the numerator angle is 0 and the denominator angle is tan inverse imaginary upon real. So when it will jump in the numerator, the sign will be negative, and minus ka tan inverse imaginary upon real, so it should be a sin omega. Imaginary upon real, so it will be a sin omega upon 1 minus ka a cos omega. Yeah. And here also, student, in this equation also, when you will put, even you can put the value omega 0. When you will put omega 0, sin 0 is 0 only. Sin 0, 0 matlab angle will be, so if I will make the angle curve also just below to this. Just below to this by small diagram I will make. So student, if you will make the small diagram just below to this, then at omega equal to 0, you will have, here is the magnitude curve, here is the angle curve, x e ki power j omega curve with respect to omega. So omega equal to 0, exactly we have 0. Then what is happening at pi by 2? Tell me. Exactly at pi by 2, what will happen? Pi by 2. You will get, sir, a value is half, okay, a value is half. Sin pi by 2 is 1, cos pi by 2 is 0, sin pi by 2 is 1, sin 90 0, sin 90 is 1, sorry, and cos 90 is 0. So cos pi by 2 0, sin pi by 2 is 1. So it will be 1 into 1 upon 1 and half. So tan inverse half. So tan inverse half value, of course it is a positive value and sign is minus. So it means curve will be negative value. Curve will contain negative value. Similarly at minus pi by 2, this is exactly at pi by 2 guys. Similarly at minus pi by 2, you will get the same value in the positive. So if you will make the entire curve na guys, if you will make the entire curve na, you will get a curve like this even. You will get a curve like this even. Yeah. Like this curve you will get. You can make even curve also. You can make even curve also. Yeah. So it is exactly at pi actually. It is exactly at pi like this. Like that you will get the curve. You can make the curve guys. You can make the curve. Yes. Make it fast. Just complete it fast. At the different values you will get the curve. Actually, if you want to match with the location, na, then again I am mapping the curve actually. 0, just below to this I am writing minus pi by 2, so that you will get the actual notation if you want to map with the frequencies also. So you should map first of all dash dash dash, so that your curve will match with the values of pi and minus pi also. So the curve will be like this guys. Curve will be like this. Yeah. Maximum and like this. And it is again repeating. It is again repeating like this. Dash dash dash. Dash dash. So it is also in continuous nature from minus pi to pi. But what is the condition? We can say that closely कि mode of x of omega we got even because it is symmetrical about y axis. This is y axis. And x of e ki power j omega is nothing but odd because it is symmetrical with respect to origin. Because it is symmetrical with respect to origin. Because it is symmetrical with respect to origin. Yes, do reply fast. Guys, do reply fast. So now we have concluded this, and do you remember in the chapter number 1 in continuous time domain we have seen the condition of conjugate symmetrical also. So conjugate symmetrical signal condition says that x omega, if conjugate symmetric satisfy, then its magnitude should be even and its angle should be odd. So because magnitude is even and odd, we can also relate with this condition that x e ki power j omega, it is my DTFT formula, and formula says that from n equal to minus infinity to infinity, x of n e ki power minus ka j omega n. So this is the my DTFT formula guys, where x of n is a discrete time signal. Discrete time signal. So because this x of n is a discrete time signal and this is x e ki power j omega, if I am looking for, if I will take conjugate both sides, then what you will get? You will get sigma of n tends to minus infinity to infinity, x conjugate of n e ki power plus ka j omega n. Yeah. And here if you will do this, ki x conjugate of e ki power minus ka j omega. If you will replace omega with minus omega, and if x of n is real, if x of n is real na, real, then actually x conjugate of n is equal to x of n. Then x conjugate of n is equal to x of n. So it will be sigma of n tends to minus infinity to infinity x of n e की power omega replaces minus तो e की power minus का j omega n. I hope this is crystal clear to you guys. Yeah, I hope this is clear to you. I hope this is clear to you. So now if you will check the right hand side part of this equation number 1 and equation number 2, you will see it is same only. It means we can say that x conjugate of e की power minus का j omega should be equal to actually x e की power j omega, and this condition is known as conjugate symmetric condition. And conjugate symmetric condition also says that it means magnitude of x e की power j omega should be even and the angle of x e की power j omega should be odd. Yeah. Conjugate symmetric condition, guys. Make it fast, guys. I am just waiting for you. Just do reply fast. Just try to reply fast. Tell me, guys, tell me it's completed or not. चलिए. So student, if we have the conclusion first box कि a की power n, u of n, the Fourier transform is what? Then we can say that the Fourier transform is nothing but 1 upon 1 minus का a e की power minus j omega, and this is only true if we have mod of a is less than 1. So if I will take the example, guys, if I will take the example कि sir, if anyone will ask about this कि half की power n u n, what is the Fourier transform, then you should not use the formulas and all. You just need to remember this box as a short trick, and if you remember this, then you can save your time and you can directly write 1 upon 1 minus का half e की power minus j. We are only eligible to apply this formula if the a value should be less than 1. Suppose that if question is like this 3n un, then you cannot write like this. If you are writing 1 upon 1 minus 3 e की power minus j omega, it is perfectly wrong. It is not possible because 3n un is an unbounded signal. It is a unbounded signal, and for the unbounded signal, if anyone examiner will ask about the DTFT, then you will reply can't determine. You should reply can't determine. So many students generally they just read this and they just remember this part and they forget the condition of A. So if question is like this, they will apply. This is wrong. This is wrong. So if the question is like this, guys, if examiner asking this 2 by 3 की power minus n un, then what is the answer? DTFT is possible or not? Now some students think कि 2 by 3 to less than 1. No. But 2 by 3 की power minus n. So when you will make it plus n, 3 by 2. 3 by 2 is greater than 1. So again Fourier transform not possible. But if I will write like this, कि sir 4 by 3 की power minus n, un, then its Fourier transform is possible. Why? Because it is equivalent to 3 by 4 की power n un. 3 by 4 की power n un, and now its Fourier transform is possible, that is 1 upon 1 minus का 3 by 4 e की power minus j. Now this is perfect, guys. This is perfect. Yeah. This is perfect. Why? Why? Because 3 by 4 is less than 1. Because 3 by 4 is less than 1. I hope this is crystal clear to you, guys. I hope this is crystal clear to you. So now students, similarly, if I want to make another important form, suppose that my question is a ki power n into u of minus n, then what will happen? Then what will happen, that we will figure out, okay. So if you will simply apply the formula also here, a e ki power u minus n. Now this time guys, this time if mod a is greater than 1 and if you will make the curve, mod a is greater than 1 and if you will make the curve now, because of u minus n, so you will get a curve like this. It is exponentially growing, but this time it is bounded. This is bounded guys this time. So Fourier transform possible this time. But a ki power n u minus n, because of u minus n, it is covering the limit from minus infinity to 0. So if you will do this, then what you will get? You will get like this. Yeah, like this you will get. So it will be 0 to infinity, and it will be what guys? It will be what guys? A ki power n. So you will get this time if mod of a value is less than 1. Sorry, not right hand side part. Sorry, a is less than 1. It means the curve will be like this. Exponential decaying, na? So it means, don't you think it is growing? It is growing at infinity. It is growing only. It is growing only. Yes or no? So that is why right now it is unbounded signal. Right now it is unbounded signal, guys. It is growing at infinity to also infinity. So it is unbounded signal. And because it is unbounded, for this time, in this case, the Fourier transform not possible. Fourier transform not possible. So because we are using u minus n rather than un, so that is why mod of a value should be greater than 1 this time. And if it is greater than 1, and if you will apply the formula, then your limit goes to what? The actual limit is minus infinity to infinity x of n e ki power minus ka j omega n. This is the formula. Now here, because of u minus n, the formula will be from n equal to minus infinity to 0, and xn value is a ki power n and e ki power minus ka j omega n. Now student, here if I will do like this, if I want to change the n value, minus infinity to 0 is the limit. So from here to here, if I will just arrange like this, a into e ki power minus j omega ki power n, right now ki power n we have. And from this equation, if I will replace n with minus n, then do you know in the summation what will happen? The limit sign also change, and it will be shift also from upper to lower, lower to upper. So then now the new limit is 0 to infinity, and here n is minus n, so a e ki power minus j omega ki power minus n. So ultimately, if minus n, if you will take inside the bracket, then it will be actually n equal to 0 to infinity a ki power minus 1 e ki power plus j omega ki power n. And now it is nothing but the simple formula, because a is greater than 1. So here is 1 by a. 1 by a is less than 1. So now you can apply this. So when you will apply, you will get 1 upon 1 minus a. So 1 upon 1 minus a inverse e ki power plus j omega. So this is the standard form. And do you know a inverse is itself 1 by a. A inverse is nothing but 1 by a. So going forward, we have to remember two box now. We have now two box. One box is this now. Now I am again making one more resultant box for you. This result you need to secure, guys. an un, the DTFT Fourier transform 1 upon 1 minus ka a e ki power minus j omega. But the condition is mod of a value should be less than 1. And this box you can also add here one more expression, a ki power n un minus n, the DTFT. Here is DTFT. Similarly, here is also DTFT. So what is the DTFT formula here? 1 upon 1 minus ka a inverse e ki power minus j omega, this time e ki power plus j omega. But what is the condition this time? Mod of a value should be greater than 1. So this is the complete box, guide. You have to remember this. Now student, if I will ask, let me take one example. Suppose that if I am asking this, find out 5 ki power n u of minus n Fourier transform. Now you should not apply the discrete time Fourier formula. If you apply the formula, you are wasting your time. You just need to remember this box. So if the box you remember, then answer is 1 upon 1 minus ka or 1 by 5 e ki power plus j omega. That's it. That's it. This is the only answer. Yeah, this is the only answer. If anyone will ask about 5 ki power minus n, u minus n, then DTFT is what? Then you will say that sir, 5 ki power minus n, it means 1 by 5 ki power n, and a is less than 1, it means can't determine. It means can't determine because this signal is unbounded. Because this signal is unbounded. I hope this is crystal clear to you. It should be clear to you guys. It should be clear to you guys. Just complete this box fast. Even I think you are doing this calculation part. So just do this calculation part. And I want that you should share your experience in the comment section also. If you are watching the session in live manner or in the future if you will watch in recording, try to make the class handwritten notes also and share your true experience in the comment section so that in future if any students will come and this video will reach to any new student, when they will see the comments, they will also have a motivation to watch the complete playlist. And they will also get to know that why this playlist is important for them. So I think guys, you guys complete this. Now I am going for the next slide also. Just complete this part also. So that's all from today's class guys. We have planned 1 hour session, 6:30 to 7:30. So guys, I think next week we will don't have the class YouTube class because I think I'm not seeing some major live students here. So no problem. Whenever you will get the time and whenever you require the session, you can write in comment section. After that, according to your requirement, we will plan the live session. Okay guys. Chaliye. So again we'll have the break in this playlist at 67 lecture. It can be 90 plus also, it can be 100 plus also, it's up to you, I am telling you. If you will tell, even if 10 students will come, will write in chat box and if they are saying that, sir, please continue this session till 100 plus, then we'll definitely continue. Okay, pyare bachcho, chaliye. Otherwise, we'll also make a recording videos and we can also make it premiere. Okay, so let me decide about this, it will take some time. So let's see it in next week. Okay guys, bye bye, take care. Love you all guys. Just do your best. हंसते रहें, मुस्कुराते रहें, खूब पढ़ते रहें और your present true effort, sincere effort definitely decide that what you will become in the future, and your in future student you will definitely have a proud when you will see your past. So just try to do your best in present days so that in future whenever you will see your past, at least you should have a proud that what amazing task and what amazing work I have did in the past. Okay, so you can only deserve success in future if you are doing your perfect, your 100% hard work in present days. Bye bye guys, that's all from today's class. You can just off it. Right now and is going on. Intro and end is running. Auto completion is the end is streaming. save the PDF.